In this Rhino Grasshopper tutorial, I want to model a parametric bench in Grasshopper, and we're going to model this from scratch from a box and control the number of sections. As you can see, I can decrease the number of these sections, and also I'm going to define a simple point on the project, which we will change that and produce the holes on the sections, which you can see here. That's going to change the overall of the project. We are also going to extract the curves of the parametric bench and put it on the ground, and also add number on the sections for fabrication. So be sure to watch the video till the end as we model that from scratch, make the sections, and finally put them on the ground. So if you can see here, I have modeled a solid to make the parametric bench and then bring it inside Grasshopper and produce a series of sections. So I'm going to just hide this, and first of all I'm going to use a box. So the box is going to be the base of the parametric bench, and we're going to make a box. The first point, the second point for the corners, and the height of the box. Okay. If we want to control the box further, we can just select it and type SOL, which is the use for the solid point on tool, and I'm going to select this. You can see that we can control the corners. If you draw a window from left to right, you can see it's going to select only the points, but if you drag it from right to left, it's also going to select the box. So be sure to drag it from left to right, and then we can just bring it up to make it a little bit, give it a more height, select the down points, and then scale it in the Y direction. I'm going to give it scale in the Y direction, and make the base of the parametric bench. Here we go. We can also select these 4 points and move it in the X direction to give it more length here. Okay, so this is the first part. The next part is that you can click, right click on this, show points or control points on and off, and turn off these points. Okay, now the next step is to use the cage edit tool. I'm going to type cage edit. You can see that we have this tool, and the reason we are using this is because we can edit the solid with a bounding box. I'm going to select the bounding box because it's going to give us a series of control points on the box, and the coordinate system is the world. That's okay. And now what we have to do here is to define the number of X, Y, and Z counts of the points. Okay, because we wanted to give this a smooth deformation on this solid, what I want to do is in the X direction, I'm going to give this 5 points. The 3 points is going to be at the start and the end and the middle, and these 2 additional points is going to be defined here. So I'm going to define them by giving an X point count with 5. In the Y direction, we only need 2 points because we don't want to mess around with the Y direction, so just 2 is enough. And in the Z count is also 2 because 2 is enough to deform the points at the top and the bottom, so I'm going to give this also 2. Okay, we just hit enter, and again you can see the bounding box. You hit enter and you can see the control points. Okay. Again, I'm going to drag a window and select the points down here, move them up in the Z direction. Be sure that you have the gumball on so you can move these points. And the next part is to move these 2 points also a little bit up. So I'm going to just select this and bring it up to give it a smooth look. If you want to select these 2 points, you can use the shift key again to use these 2 points and give it a better look, maybe something like that. And again, hit the right click on these show points off and on, and get rid of this cage edit, so we can just delete that. Okay, that's the first step. The next step is to give that a little of extrusion in the X direction, and the reason we are doing this is because we want to put this parametric bench on the ground. So some of the section has to be on the ground. We can use the Control Shift and click this, and in the X direction you can see this small circle. I'm going to click on this and say minus, because the direction is going to be minus maybe 15. That's okay. And again, Control Shift, this time plus 15. And now we will have the base of this model to use it in Grasshopper. Okay, let's go into Grasshopper and bring it inside. So first of all, we have to go to the params section, and in the geometry, I'm going to use this brep or boundary representation, which can import a solid. Let me put the bifocals plugin, and here we have the brep. I'm going to right click and set this to the parametric bench, and now we will have that in Grasshopper. Let's just select it and turn it off so we don't see it in Rhino. Okay, that's the first step of importing this in Grasshopper. The next step is to produce a series of sections on this, right? Because we want to fabricate it. You can use two methods to do that. The first one is in the intersection and physical, in the mathematical, excuse me, you have two options. One is the contour tool, which produces a series of sections, and the second one is the brep plane. I'm going to go with the brep plane because I'm going to use a line to use a series of perpendicular frames to do that. You can also use the contour if you want to produce the sections, but the problem with the contour is that when you want to produce a series of sections, you have to give this a starting point, a direction, and a distance of contouring, and then it's going to produce a series of sections. At the end, it's going to either miss this or it's going to go outside that, okay? But when you use the brep plane, we can simply, okay, we want to section this brep, we have to give it a series of plane. The reason we use that is that we can control the planes here with this technique I'm going to use. So let's just turn back on this. I'm going to draw a line, a simple polyline or a line, and draw it from here. Be sure that the O-snap is on and you have this end near and point and these things on. I'm going to select this from end to end. We just move this in the y direction so you can see it. That's the line we want to make the section. So for now, we have two parameters to control. You have to make the solid in Rhino. You have to make the line of the section. Let's go to the params and import that as a curve. So that's a simple curve or a line. Set this to a curve, and we have this in Grasshopper. Okay, now I'm going to go to the curve section, and there's a great tool called perpendicular frames. We have also another tutorial on perpendicular frames. I'm going to put that in the card section up there. You can check it out. For now, you can use this perpendicular frame to produce a series of perpendicular frames on a curve. Let me just go to the display and preview plane size, put that to maybe 8, so you can see those planes. Okay, and if you give it to a curve, you can give it a count. So we can just say from 3 to 12, and we can increase that even by double clicking the number slider and increasing the maximum number. Okay, so that is going to produce the frames, and those frames or the planes are going to intersect with that, and we will have a good intersection. At the start and the end, we will have the results. That's it. The next part is also going to define the pipes, but for now, let's just turn everything off and also turn this off, preview off, and now we have these curves. Okay, to make them a little bit smoother, I'm going to go to the curve section and use this fillet to make them a little bit smoother. So I'm going to give this to the curve, and let's just give this a radius 0.25. and by increasing that, you can see that you can smooth that. By turning off the sections, you can see the smooth results, not both of them, and then we can increase that even if you want to make that smoother, like that. So that's how we can use this for the fillet. So now we have this smooth results. Let's go to the next stage, and that is to produce the series of pipes, which is going to be, let me show you here. You can see that we need those pipes for the intersections, and then it's going to give us the final results. So let's go back to the curves and produce the pipe. I'm going to go to the right section, and you can see it here like that. Let's define two series of points. So I'm going to go to the Params menu and select a point. And one point is going to be the location of one of those pipes. That's the reason I'm doing this. Another point is going to be, if we go to the perspective and Control Z to bring that back, the next point I'm going to set this at the middle of here. Be sure that the mid is on, and I'm going to set it here. The reason is that if we select this and give it an XZ plane, it's going to be the mirror of that second point we need. Doesn't matter where it is, in the right section, we can just make a mirror of this point. So let's just type this MIR, mirror, and use a mirror of this point with this plane. That is how we can control the location of the pipes and make it symmetric and give it a symmetry. So when we change this, the second one is also going to move. Okay, that's the way we are going to produce the location of those. So let's just turn this off. Okay, how can we draw the lines? If we put that point on the first section, it's going to produce that points, and then we can just define it based on the line. Okay, so how can we do that? We can say projection. So I'm going to type projection and use this project along, because we want to project that on a plane, or you can use this project point. So if you want to project that, you can do that. No. So now we have to draw a lines that goes outside these curves to make that possible. I'm going to use the curve and use this SDL, start direction length, to produce the lines. We can use a point tool to bring the first one and the second one inside a container, and then give it to here. That's it. The direction is going to be in the X direction. And in the X direction, we can give the length of that base line, which we have used. This is a technique you can use. You can give it a number from the Params menu and give it here to the length. Okay, that's how you can make it happen. Then what we need to do is to extend it in the also -X direction. So I'm going to just type extend curve, extend line. The type of the extension is going to be line. That's okay. And we have a start and end. So if we want to, we have to increase that in the start. So I'm going to give that also number to the start. The end doesn't have to be increased. We can just double click 2 forward slashes and 0 to give it a number of end, like that. So even if that point comes inside one of these curves, it's going to increase and go outside the sections and make it possible to make that. Okay, so we can go to the right now, and obviously by changing the point, it's going to give us a freedom for choosing the location of the pipes. And now we can just say pipe. You can find it in the surface, and here in the pipe section. Give it to the pipe and a radius. And that's it. That's how we can do that. And now when we have the pipe, we have to also find the intersection of this pipe with these planes. So it's going to be obviously like this. Let's just copy this, Control C, Control V, bring it forward, and give this to the pipes. Turn it on. You can see beautifully. Let's just turn the pipe off, the extended curve off. You can select all of them and turn it off. And then you can have this, here's the pipes, in all of those sections. That's it. So now we have all of them in the sections we want to make. And let's just bring this also with a curve. I'm going to put them in a curve container and bring it right here. We don't need anything. I'm going to turn everything off and have these two. Okay, if you want to make a surface from these, we can just select the surface and use this boundary surface to make it. The boundary surface, if I put this curves and use the shift key to add this up, you can see it's going to make it, but there is a problem. If I bake this, you can see that we have the surface, one of the holes are working, is working, and the second one is not. So how can we get rid of that? We can just right click and flatten this. So all of them are going to be applied once. Turn this off, and you can see that we have these surfaces in 3D if we want to show them. And I'm going to also extrude that so you can see them in 3D. The technique I'm going to use is that assume that we have this curve and we want to give it extrusion, and the thickness is, for example, it's T, okay? What I want to do is to move that in one of the directions. For example, in the X direction, I'm going to move that like T divided by 2, and then when I have the surface here, I can extrude it back by T, and that's going to give the curve exactly at the center of the solid. So if we have the solid here, the curve is going to be exactly at the center. Let's do that by using the move in the X direction, and now let's define a thickness. So I'm going to say maybe 2.2, and in the motion we can right click and use this expression and type x divided by 2. X means the input is divided by 2, and then we can extrude that by ext, extrude, or you can find it in the surface, freeform and extrude, and we can extrude that in the x direction exactly. But it's in the same direction we moved it, so we're going to go to the direction, expression, and type -x. That's going to put that in the opposite direction, and that's the way we can put that curve and the surface exactly at the center, and it's better for visualization. The fabrication is more accurate, and then we have the results. Okay, let's just turn everything off, and we can see that we have this solids like that. Okay, the next part is to let's also go to the pipes and make the pipes visible for these lines. So what I want to do here is to make this split. Let's go to the intersection region and split it with a B-rep. That means I want to split those curves. Let me just turn them on and split it with the box, which is like that. So that's going to be easy. The parametric bench is going to go to the B-rep, which is going to split it and bring it here in the curve. Turn everything off. And now you can see that these curves, there are two pipes. Each of them has three different parts. That means the first part, the second part, and the third part. And now we have to pick up the second one. So I'm going to go to the selection set and list item for selecting and give it to the list. And the index is going to be, so it's going to be like 0, 1, and 2. I'm going to pick up 1, turn this off. You can see that we have that inside it. And now we can give it a pipe. You can also download this example file from our website, so be sure to check it out. And we're going to give this radius to here, and that's how we can make it. That's it. We can also use that for visualization. Okay, the last part which we wanted to produce those sections for fabrication is to put the surfaces, the boundary surfaces, on the ground. What I want to do is to use the orientation, which is the orient tool. And the orient tool, you can also find it in transform. Here you can find it in Euclidean orient. It's going to put an object or geometry from a source plane, which is the plane of these surfaces, on a target plane, which is on the ground. So what I want to do is to say these surfaces, the source plane is obviously the plane we had here for the perpendicular frames. I'm going to say, okay, this is the source. Turn this off. And now we have the target, which is the ground. The default is XY, and you can see that they are all sitting on the ground, obviously for fabrication. But let's just go one step forward. We want to stack them on each other. I'm going to give you a simple technique we can use. We can go to the Params menu, select the box. And now what we want to do here is to put and move these based on the height of this box. Okay, that's the height of the box. So I'm going to explode the box, going to the surface, and use this deconstruct the brep. We have to also pick up the edges. So again, the set list item, and we are lucky. The first one is the edges that we need. Then what we have to do here is to find the length of these edges. So I'm going to go to the Params menu and select this number. So it's going to find the length of these. And then with a cool technique in the math, and use this mass addition, I'm going to give it to input. But be sure to flatten this, because we need these numbers to stack on each other for the partial results. And if you don't know about flatten or graft, I'm going to put up a video up here so you can check it out and learn about flatten and graft those things. For now, we have a partial result. That means 33, 66, and up to that we're going to move them. So for example, if I say move these oriented curves or surfaces in the x direction and give it to the partial results, let's turn this off. You can see that's beautifully sitting on each other. That's really great. You can use other nesting plugins or techniques, but for now this is also a small technique you can use. Okay, now we have to also add a little bit of a gap to these things. So what I want to do is to give this partial results a little bit of addition. So I'm going to go to the math and add this up. So I'm going to go to the partial results and multiply that with a multiplication. The reason I'm using the multiplication is that it's going to give this a little bit of addition, like 1.2 is going to increase the distance. If it's smaller than 1, obviously it's going to collapse, so we can just make this from 1 to fitting those curves on together, and maybe 2 for more of the gapping. So you can also use that for a gap. And now we have those curves on the ground. We can also go to the surface analyzers and use this brep wireframe to make the curves extracted, but you can see that all of them have 10. All of them has 10 curves. So what I want to do here is to join them together. Going to curve and select this join curves. Okay. Now we can see that we have like 3, which is like 1, 2, 3. If I bake that, you can see that we can have this final results. Okay. Now that we have them, we have to number on these things. What we have to do is to just again select a box on these curves. It's going to give us a box. And another technique we can use is go to the surface, and in the analyzers we can use this evaluate box. It's a little cool thing you can use. Give it to the box, and now be sure to produce a box from all of these sections. You can see that each of these 3 curves has the box. So I'm going to delete this box, go to the surface, and select this bounding box. Bounding box, right click and union box. Union box is going to make a box from all of those 3 and then give it to the evaluate. Okay, the U and the V parameter is between 0 and 1. We don't have a W because that is going to go with the thickness or the height. So I'm going to just change the U from 0 to 1. You can see that's going to go up and down. It's at the center, so the V parameter is 0.5. You can put that to the 0.5, so it's the center, but you can change it also if you want to. But for now, we just want to use the U parameter to move the location of the numbering. So we'll have that. And then what we have to do is to number that with the display and use this text tag 3D. Okay, the location is going to be here. What do we want to write? Remember to flatten this so all of those planes be inside one group, because the text has also to be in one group. I'm going to make it a series and make it from 0 starting. The step is going to be 1, and the count is also going to be the number of these sections we had on the orient. Let's find them by going, or you can use this number 18, which is going to give you 19 frames. So I'm going to just also use this number and go to expression x plus 1. Okay, that's going to give us the numbers, and we can give it to the text. You can see it here. If you want to rotate the plane, it's really easy. Just type rotate plane and give it an angle of degrees and set number to maybe 90 degrees or minus 90 degrees based on your project, whatever direction you want to put that. And then you can also go to justification and select the middle center. You can see it's at the middle center. We can turn this off. We need the curves. You can see that we have them in numbers. Let's increase the size of the text. And you can see that we can increase that. That's how we can put the numbers and move it a little bit up like this. Okay, that was the tutorial of how you can make the sections. You can see that by increasing or decreasing the number of the division, it's going to also update the number of sections here. It's really obvious. You can increase the radius of the pipes like that. You can increase the thickness like this, and then you will have this parametric bench with the sections sitting on the ground. I hope that this tutorial was useful, and be sure to subscribe to our channel, like this video so you can see more of our videos, our channel videos, And thanks for watching. See you next time. Bye.